Today, we're going to build an AI-based recipe generator that uses only local AI models. So first off, why a recipe generator? Well, A, it's kind of a fun project, maybe even useful, but also it's a nice way to experiment with both text and image models. So the end result can be a nice recipe with the preparation steps, list of ingredients and everything, but also a nice image of either the final dish or one of the preparation steps. Hi, I'm Mirko. I've spent a couple of decades building products at startups and Google, as well as leading teams, and now I'm having fun with experiments like this under the Gamma Vibe Labs umbrella. So thanks for joining me for this latest experiment. I've done a lot of work with various AI models, including Gemini, OpenAI, and others. But recently, I've been curious about local AI models. Those have actually come a long way. And since I have a decent PC, even if it's a couple of years old now, so it has a NVIDIA GeForce 4090 with 24 gigs of video RAM, I have an Intel i9 13900K CPU, 64 gigs of RAM, and so on. So it's a decent system, but not top shelf. But I wanted to see if this is solid enough for building a proper AI app that only uses local models. So a lot of models have been released. Most recently, Google actually released the new Gemma 4 models, or rather family of models. And I've been really impressed with them in my initial experiments. Here you see an overview of the Gemma 4 model, the capabilities that they support, including reasoning, as well as multimodal support. In this case, that doesn't mean generating images or video, but rather understanding these and then turning them into text. They have good context windows. They can be used for coding. I'll probably explore that in a future video. Here you see the memory requirements for the different models that are part of the family. So you can see they're quite different. Down here, they talk a little bit about the differences between them. So for example, the 26B A4B model is a so-called mixture of experts model. So what that means is that while the model has the data that you would expect for a model with 26 billion parameters, it actually only uses about 4 billion parameters at inference time. So it's actually much faster than you would expect. In my experience, this one actually works great for interactive chat sessions. I haven't had as much success with this one for my code-based pipelines. I've had more success with the E4B model, but we'll see that shortly when we get to the actual code. And there are a couple of ways you can run these models locally. One of the easiest ones is using the Ollama app. So if you go to ollama.com, you can simply install Ollama on your system by copying this command. This here is for Windows, but they will show similar commands for Mac and Linux. So it works just fine on any platform. Once you've installed Ollama, you'll need to download a model. There's a couple of ways to do this. Let's take a quick look here. So here I am in my Windows PowerShell. Here we see the Ollama help. So for example, Ollama list will show all the models that I have installed. So you see here, there are the different variations of Gemma 4. You can also see that they've aliased the E4B model to latest, right? These have the same ID and same size. Then I have the larger 26B model. I also have the even larger 31B model. So if you didn't have these installed yet, you could use the pull command above. So you could do something like Ollama pull Gemma 4 E4B, or you could just do Gemma 4 and it would download the default one, so the E4B model in this case. You can also type Ollama PS, which will show which models are currently running. So right now it's not running any of them. Basically, the Ollama app is both an interactive app that you can use for chat sessions and for installing models, but it also acts as a server that actually serves up the models over HTTP, so you can hit them from your apps. It's smart about loading models into your GPU when you need them, and then unloading them after some time of inactivity. I think it's like 5 minutes or so. So it smartly manages all of that. Depending on your GPU and the size of the models that you're using, it might even be able to keep multiple of them loaded at the same time. So let's quickly show an interactive chat session. Yeah, the easiest thing is to just start Ollama like this. And it actually gives you kind of a nice menu here. It even has some convenience features, so you can launch OpenClaw if you want, or, Cloud Code, OpenCode, a bunch of stuff in here. The simplest thing you can do is just chat with a model. So I'm going to select this. See, now it's spinning, so it's actually loading the model. And now I basically have an interactive chat session. So if I send a message like this, Monty Python fans will recognize this one. So what's the airspeed velocity of an unladen swallow? And you'll actually see this model. It actually is a reasoning model. So it outlines its thinking process. And then it responds here. You're asking for the legendary airspeed velocity of the African or European swallow. While science cannot definitively answer this, especially given the historical nature of the question, the speed is generally accepted to be subject to a considerable amount of continental ambiguity and comedic exaggeration. Anyway, so that's the local model here. Feel free to play with this more at your leisure. Maybe show one more thing. So /? will show you the available commands. /show info should show me some information about the model. Okay. 8b. I think this might be the E4b model, perhaps. All right, we'll exit out of this. Quickly show Ollama PS again, because now there should be a model running. There we go. Yeah, this was the E4b model, which is aliased to Gemma 4 latest. And that's the one we're going to be using in the app as well. One more thing to show here. So when Ollama is running, you can hit localhost on port 11434, and it should say Ollama is running. And then when you hit /v1/models, it'll actually show you all the models that you have installed. And then one more note, if you go to the Ollama website, you can see a whole bunch of other models. So in addition to Gemma 4, there are a lot of popular models like Mistral. Qwen is a very popular one. So those might be worth experimenting with. Kimi, DeepSeek, and so on. So it's a really convenient way to do this. All right, so here we're looking at my IDE, Visual Studio Code. I just find it easier to use this for tutorials. You can do all of this in the terminal or whatever your editor of choice is. So I already created a directory here for the local recipe generator with a git ignore. And otherwise it's still empty. By the way, I'm going to be sharing all this code. So if you don't want to type it in, feel free to just pull it from my GitHub repo. I will put the link in the video description. So the first thing we're going to do is use UV, the Python package manager that I use to initialize a new Python project. So we'll just type UV in it. We have an empty pyproject.toml, and we have an empty main file that doesn't do anything yet. So we can start filling this out. One more thing to mention, we'll be using Pydantic AI. So Pydantic itself is a validation library for Python that makes it easy to define model classes and then validate API responses and things like that. And then Pydantic AI builds up on top of that and provides a nice AI framework that allows you to talk to pretty much any AI provider, including local models like we're using with Ollama. This actually is compatible with the OpenAI API. So Pydantic AI is a nice wrapper for all of those, and it nicely handles schema validation here as well. so we can make sure that the model responses adhere to the model definitions that we use. So I've had great success with this, highly recommend it. So we'll have a few more dependencies later, but for now, we're just gonna do UV add Pydantic AI. Okay, so there it is, downloading it, creating my Python virtual environment. There we go. In the pyproject.toml, we have our Pydantic AI dependency. uv.log has a bunch of stuff in it now as well. So that's a good foundation. I'm actually going to commit this to Git as a starting point. Okay, one more thing. Even though there isn't any real functionality yet, I like to just run my main script once just to make sure everything is wired up correctly. So that should work. Hello from local recipe generator. All right, perfect. So let's start actually filling this in. Okay, we'll start with a few imports that we're going to need later. And then we'll define some constants here. So we have a constant for the model that we're using. So Gemma 4:E4b. That makes it easy for us to experiment with other models later. Then we're pointing to the Ollama host. So as we saw earlier, this is running on localhost, port 11434. And then this Ollama URL, basically that plus v1. So the next thing we need to do now that we have Pydantic is to actually define some Pydantic models. One nice thing about using something like Pydantic is that we can actually define models with specific fields and things like that, and then use that for validating the API responses from the LLM. So if we think about our recipe app, right, we probably need a model that represents the dish that we're creating. A dish might have a name and a description. Then there's the recipe itself. So the recipe might add a list of ingredients, where each ingredient probably has a name and a quantity. So we might need, 3 cans of diced tomatoes or something. And then we need a list of preparation step, where each step describes what we do at that step. So I'll take a stab at writing some of those model classes. Okay, here we go. So actually, before we talk about the model classes, one more thing. We didn't talk about exactly how this app will work yet. So here's how I'm envisioning this. This will be a simple terminal app. So you will run this from the terminal. Then the app should prompt the user to type in what they're in the mood for. So just some free text. This could be something very specific, or it could be something pretty open-ended, like, a dessert with fruit, or maybe a stir fry with a lot of veggies, or, however specific they want to be. Then the app should come back and suggest a couple of specific dishes that would fit that description. And then the user can pick one of those. And then the app will return the actual recipe. And then we'll build up a little bit on top of that. We'll add image generation and things like that. But that'll be sort of the base behavior of the application. So here are the models that I came up with to support that. Each one is very simple, right? So it's just a class that extends base model, which is the base class for all Pydantic models. And it defines a number of fields. For each one, it defines what type of field we're dealing with. And then it also adds a description. The description is actually really important. It's not just for us, so we understand what this is about, but these descriptions actually get passed to the LLM as well, and essentially help the LLM figure out what it should be returning here. So this is a good place to describe examples of possible responses and things like that. So let's take a look. So we have our dish model. We have a name with a maximum length of 80. And the description is short dish name, for example, crispy corn fritters, maximum 80 characters. We also have a one-line description, so a little bit longer, 200 characters. And then we have a dish list. So this is a list of 3 to 5 dishes, right? So this will be essentially the output of the first step. After the user has typed in their preferences, the model will return a dish list and will then present that to the user to choose one from. And then for the actual recipe step, so we need to first define what an individual ingredient looks like. So an ingredient, again, has a name, up to 80 characters. For example, all-purpose flour. And we need a quantity. So we'll keep this as a string field because depending on what we're dealing with, right, this might be measured in a count, so like 2 of something, or it might be like 2 cups or 1 tablespoon or whatever unit we're dealing with, maybe 6 ounces, right, something like that. And then we have the recipe itself. So this, again, will have a name, we'll have the description, and then we'll have a list of ingredients. So here we're referencing the ingredient class above. And finally, we have the preparation steps. So that's just a list of strings, ordered preparation steps. Each list item is 1 step as a full sentence, maximum 400 characters. So that should be all we need in terms of models. So the next step is to start wiring things up. So let's start with just 1 step, right? So just to make sure that we can actually hit our local Gemma 4 model, let's just have the user type in what they're in the mood for, and then come back with a list of suggested dishes. And then we can build the rest of it after that. Okay, so here is the first step implementation. This is still untested. We may need to make some more tweaks here. So let's take a look down here. So I changed the main function to be async. A lot of the Pydantic calls that we're making are async. I think they have ways of making synchronous calls as well, but this will be a little bit more straightforward. So in the main function, we're first going to build the model. We'll look at that in a second. Then we'll prompt the user, right? So we'll say, what are you in the mood for? And then just let them type in whatever text they want. And then we're calling suggest dishes, which we'll look at closely in a moment. We'll pass in both the model and the user and the mood text that the user entered. And finally, we'll let the user actually pick one of the dishes that the model returned. And just print it out for now. So this is later where we would make another LLM call to generate the actual recipe. So scrolling up a bit. So in build model, you'll see that we're returning an OpenAI chat model. So that's one of the Pydantic AI classes. As I mentioned earlier, Ollama basically provides a OpenAI compatible API. So that's why we're using the OpenAI provider. We'll give it the Ollama URL, so our localhost URL as the base URL. We don't need an API key other than Ollama. And then for the model itself, we'll give it the model name. So again, here we defined the constant Gemma 4 E4B, but we could specify any of the installed models, and Ollama would automatically load it if needed. So just a couple of lines, really. And then this is the meat of it. So suggest dishes. So we pass in our model and the mood string. And then we're generating this agent object. So this is another Pydantic AI class. So there's a bunch of things you can pass in here. And it's possible that we might need to make some tweaks. This can be a bit finicky with these smaller local models. But for now, let's try this. So we'll just pass in the model. We're specifying tool output as the output type. So basically, Pydantic AI has a couple of different ways of handling output from the LLM. You can specify a schema that essentially just tells the LLM, hey, please use this JSON schema. And that often works. But an even more reliable approach is this tool calling mechanism. I think that's actually what Pydantic AI uses by default as well. We'll just explicitly request this here because I found this to be very reliable. So we're basically saying we're using tool output as the mechanism, and then we're passing in dishlist as the object that we expect to get back, right? So the LLM should respond with this dishlist object that we defined above. So essentially a list of dishes wrapped in this class. We're asking for 3 retries. Sometimes these calls don't work the first time, and Pydantic will automatically retry a couple of times if we pass in this parameter. And then perhaps most importantly, we have this system prompt. So in the system prompt, we're basically telling the LLM to act as a creative chef, right? So you are a creative chef. Given the user's mood or craving, suggest dishes that fit. Favor variety across cuisines, textures, and preparation styles rather than minor variants of the same dish. Obviously, be creative here, right? You could totally tweak this based on your preferences. Another thing worth pointing out, I added some logging. If we go up here, I just added this basic logging config. I found that this is super helpful for debugging, so I just preemptively added it here. This way, we can log the API requests and responses and things like that. So going back down here, so we're going to log the call that we're about to make. We'll also log how long it took. We're remembering the time now, and then later we can calculate the duration and log that as well. But yeah, this is the actual LLM call. So we're calling agent.run. We're giving it a super simple user prompt. So we're just saying, I'm in the mood for, and then pass in the mood string. And then it'll hit Ollama and hopefully respond in the right format. So this output should ultimately be a dish list that we're then returning. And then pick dish is really simple. We'll just print out all the dishes. For convenience, we're numbering them with a 1-based index here. Let the user type that in and then convert it back to the actual dish. So let's kick this off and see what happens. It's possible that we'll need to dial in the temperature of the model a little bit or other tweaks. Let's see. Okay, so it's asking us what we're in the mood for. How about a vegetarian stir fry? Okay, so it's hitting the Gemma model. Well, there we go. That actually worked fine on the first try. So let's take a look at the suggested dishes. So first we have a Thai peanut tofu stir fry. I'm actually already sold right there. So peanut glazed tofu and crisp vegetables in a spicy sweet Thai coconut sauce. That sounds amazing. I might need to make this for dinner. Oriental mushroom and water chestnut stir fry. Umami-rich mix of exotic mushrooms and water chestnuts in a classic soy glaze. That's also not bad. Curried Indian cauliflower stir fry. Spiced, earthy vegetables infused with warm Indian spices like turmeric and curry. And finally, Vietnamese herb noodle stir fry. Fresh rice noodles and marinated tempeh tossed with bright Vietnamese herbs and hoisin. Can't go wrong with any of those, to be honest, but number 1 is, I think, my top choice here. So I'll pick that. And for now, we're just printing that, and that's it. But this is actually really promising. This means that all the Pydantic AI plumbing is working well, the tool calling, and all of that. So everything else should be really straightforward from here. So let's add the remaining code. Okay, so now I added the recipe step. So it follows the same pattern, right? So after we've chosen the dish, we're now calling getRecipe, pass in the dish that they chose, and then we get a recipe back, and then we'll just print it out. Printing it out, we basically just do some basic formatting here to print out the name and description, the list of ingredients, and the preparation steps. Later on, we'll actually print this to Markdown instead, along with the image, so we can have a little bit of a nicer output. And then get recipe. Let's scroll up a bit actually so you can see both of these, right? So they follow the same exact pattern. So again, we're creating an agent. This time we're specifying tool output recipe as the output type. And then our system prompt is pretty similar. So now we're saying you are a chef, given a dish name, produce a complete recipe that a home cook could realistically follow. Sensible quantities, common ingredients where possible, and steps in the order a cook would actually do them. So this should give us something that's actually pretty usable. And then, yeah, same kind of logging, and then just returning the model's output. So let's kick this off. What are we in the mood for now? Maybe something sweet. How about a dessert with nuts and chocolate? Maybe that's too specific, but I'm sure it can come up with some variations on this. Okay, yeah, there's a couple different ones. So a chocolate pecan sea salt tart, enjoyed with ice cream. Almond hazelnut panna cotta, Mexican spiced chocolate mole crumble, and chocolate-coated nut lattice brittle. Damn, let's do the panna cotta. So I'll select this. Now let's see if we get the full recipe back. And look at that. Very nice. So almond and hazelnut panna cotta. This is a rich, velvety Italian cream dessert, delicately scented with the warm sweetness of almonds and the earthy notes of roasted hazelnuts. The panna cotta is set until perfectly wobbly, making it an elegant finish to any meal. Even the prose is pretty decent, I'd say. So here we have our list of ingredients. And again, this was all returned as structured information, right? It's not just text that the LLM returned, but it actually fit into the Pydantic model-based schema that we provided. Let's maybe quickly switch back to this just as a refresher, right? So what the model actually returned was this recipe object. So the dish name, description, a list of ingredients, which in turn is a separate model, and then a list of preparation steps as strings. And then we're just rendering this output here. Obviously, we could have done something much simpler here, but the main purpose is to demonstrate that the local model can actually return structured information. So you could build all kinds of sophisticated pipelines with this that really depend a lot more on having this structure. But as we'll see in the next step, when we generate the image, this will actually come in handy even for this basic recipe example. So yeah, here's our list of ingredients. That's very solid. And then we have the instructions. So I'm not going to read through all of this, but I think this is working really well. I'm actually going to commit the changes that we have. Okay, so I find a recipe works much better when there's a nice image along with it. So that's a good opportunity to try out a local image model. So we need two pieces here. We need a library for actually calling the local image model, and then we need the image model itself. And in some ways, this is actually easier than the text-based model that we used for the recipe. If you remember, we actually had to install Ollama, and it runs essentially its own server and manages, loading the models and all of that stuff. For image generation, we can use the Python Diffusers library. So that's a library by Hugging Face, another company that's big on AI stuff. So the Diffusers library will actually manage all of this stuff straight from Python. So we can just use this to call the model, and it'll download it the first time and all of that. So it's very, very convenient to use. And then for the actual model, There are a lot of options you can experiment with. I've had good success with this one here. So flux.1-schnell, which, fun fact, is German for fast. This is a nice model that's actually pretty small and fast, and still returns really good results. So it's a great option for running locally for a pipeline like this. And one thing you do need in order to actually use this is you're going to need to create a Hugging Face account and then generate an access token. You'll want to write that token down somewhere because after you generate it, you won't be able to get to it anymore. And then you can either put it into a .env file or whatever mechanism is most convenient for you. So I will just set it in an environment variable, and then the library can find it from there. But yeah, in a production app, you would want to use an env file or something like that. All right, let's take a look at this code. We might need to make a few more tweaks, but let's see. So we had to add a bunch more imports, right? So we're importing the Diffusers library, a couple of other libraries. Down here, we're defining the image model name. So Black Forest Labs flux.1-schnell. We needed another Pydantic model for the image prompt. So we're going to use two steps here to generate the image. The first step is going to be to generate a nice image prompt. And this step will actually be smart about thinking about what kind of image would best showcase this recipe, whether it's an image of the final dish or maybe one of the preparation steps. So the image prompt has this literal here, which can either be final dish or preparation stage, right? And then the description says what the image should depict. Choose final dish for a plated shot of the finished recipe, or preparation stage for a compelling interim moment. For example, ingredients laid out, dough being kneaded, sauce reducing. Pick whichever is more visually interesting for this recipe. And then we have the prompt itself. So a concise Flux-style image prompt, 40 to 55 words, under 300 characters, describes subject, composition, lighting, and mood. Flux's clip encoder only reads the first 77 tokens, about 50 words, so every word counts. Do not include negative prompts. So this took a little bit of trial and error, but you'll see if you end up if you try very long image prompts, you'll actually get some warnings, and it'll basically ignore everything afterwards. So these instructions will help us make sure that the prompt is most effective. By the way, we're just tossing everything into this single file. In a real production app, I would factor things out a little bit more, probably break the image generation code out into a separate file and so on. But for this proof of concept, hopefully this should be fine. So scrolling down, here's another function just like the others that we had, right? So this is where we generate the image prompt. So we're creating another agent, uses tool output with the image prompt as the output type. And then here's the system prompt. So you are a food photography art director. Given a recipe, produce a single, concise image prompt for flux.1. Decide whether a plated final dish or an interim preparation moment would be most visually compelling. Then write a prompt. So mostly similar to what we had above. I'm not going to read through this, but you get the idea. Yeah, so here's the actual image generation code. So first we have this load pipeline function. And by the way, this is where you can do a lot of tuning based on your system. So if you have a really beefy GPU, you might be able to keep the whole Flux model in RAM. One challenge that I have here is that I'm using both Ollama and the Flux image model in quick succession, right? So Ollama will still have the Gemma model loaded, which means that a lot of my GPU's RAM is already taken up. So I need to make sure to use this approach here, so enable sequential CPU offload, which basically allows it to offload some of this to the CPU from the GPU. So there's a lot of tuning you can do. Take a look at the documentation and so on. By the way, Claude Code originally helped me write a bunch of this code. So Claude is really good with this stuff. So I encourage you to experiment with that as well. So I'm not going to go into these lines in detail, but this is where we load the pipeline. And initially, this is where it'll download the model from the Hugging Face. So this will download like 20 gigs or something. So this might take a moment the first time you run this. Afterwards, it should be fast. And then the actual generate image function, I'm just hard coding the dimensions here. So I'm using 1344 by 768. So something that might work well as a header image for a blog post, for example. So we're loading the pipeline. There's some boilerplate code here, some logging. And then we actually call the Flux model. And then finally, we write the generated image to the file system. We're creating the directory first if needed. And that's pretty much it. So it's actually not a lot of lines of code, as you see, to create an image using a local model. Yeah, and then a few lines added to the main method. So similar to before, this is what we call generate image prompt, printing the result, and then we call the other function to generate the image. So let's kick it off and see if it actually works. By the way, we had to add a few more libraries as well. Right, so we basically used this command here, uv-add, diffusers, torch, transformers, and accelerate. So that added all of these to our PyProject toml file. Okay, there's some output here. I think I might actually want to install Torch Vision. So let's do that. That should get rid of this warning. So uv-add Torch Vision. That's one that I forgot. So let's try this now. All right. How about, okay, let's be evil. Some comfort food, perhaps something deep fried. Let's see what suggestions we get here. All right. Southern style crispy fried chicken, arancini di ragù siciliano, assorted vegetable tempura basket, mushroom Gruyere croquettes. I think I'm going to go for the last one. So let's do that. Okay, so it should be getting the recipe now. And then hopefully an image after that. The image might take a minute or so, since we're having to offload some of the processing to the CPU. Okay, so the recipe itself looks good. We're getting some errors, unfortunately. All right, attribute error. Module datetime has no attribute now. All right, just a minor issue in my imports that should be cleaned up. Let's try this again. Unfortunately, we'll have to start back at the beginning. If I wanted to, I could add some caching here, write the recipe to JSON, and then be able to resume from there. So I'll leave that as exercise for you. Well, let's see, maybe a savory casserole. How about that? Okay, let's go with how about the green curry vegetable and tofu bake? That sounds pretty good, actually. Okay, we should be getting the full recipe now. All right, another error. I'm actually just going to run this one more time and see if maybe this is a fluke, because sometimes local models, well, models in general, but especially these smaller local models, don't quite return the schema that we were expecting. So let's see if it goes away. Let's go with the Chipotle sweet potato enchilada bake. So see if we get the recipe this time. All right, so I broke something, clearly. I'm actually going to be lazy and enlist my friend Claude Code to see if Claude can help me figure out what's going on here. Okay, so I'm just going to say I'm getting this error when generating the recipe. Please figure out the root cause. This was working before I added the image generation logic. Then I'm going to paste the whole log in here. Interesting, it's actually making git calls to see what code changed. Checking version. Sure. So it's creating a little Python script to try to reproduce the issue. Sure, let's do that. So it looks like the reproducer succeeded once, but then the second time it actually was able to reproduce the failure. So curious if this helps Claude figure out the root cause. It's definitely possible that the model just sometimes doesn't succeed. There are a bunch of levers that we have that could help with this. So we could play with the temperature and other model settings. Okay, so it says it found the root cause. Let's see. This isn't caused by the image generation code. That path was never touched. I didn't really expect the image code to be directly related. The failure is a flaky three-way interaction between Gemma, Pydantic AI, and Ollama that you happened to dodge in earlier runs. I caught it on the second reproduction with a body-dumping HTTPX interceptor. Trace. Okay, so first one, initial request goes out with tool choice required. Gemma returns text content and a final result tool call and a reasoning field. Turn 2, Pydantic AI validates the tool args. Something fails. For example, ingredients have an extra unit field that's not in your schema. Sends a retry. Gemma replies with literally just role assistant content empty. Okay. A useless response. Turn 3. Pydantic AI parses that empty response as a model response with 0 parts. When it remaps that response back into the conversation history for the next retry, the code hits the else branch. All right. So the chain is Gemma's tool calling is sloppy, sometimes adds bogus fields, sometimes returns empty replies. Pydantic AI's retry produces a content null assistant message. Ollama refuses it. And I think that's totally fair. So tool calling is definitely a bit hit and miss. I've bumped into some issues in the past and thought I had dialed it in the right way with the right choice of model. So it says we just hit a lucky seed before. Sure, fair enough. Oh, interesting. It also looks like it pulled a new model version just now. So it's possible that that's related as well, that there's a regression there. Yeah, so this is sort of what I was getting at earlier. So Claude suggests that we could use native output instead of tool output. So that's another alternative way for Gemma and Ollama to return the result rather than tool calling. Or it suggests using a different model or lowering the temperature. In fact, that's what I had some success with before. So let's try the temperature first, actually. So I'm going to say, let's stick with tool output for now, but try lowering the temperature to 0.2. I don't think we need to go quite to 0 just yet. So let's actually try 0.2. And then I'll just ask Claude to make this change and use a constant so we can easily tweak this later. Sorry, I guess we're sort of ad hoc switching to agentic engineering here, but that way I don't need to look up the syntax for passing in the model settings. Okay, great. Claude is done. So looks like it added the temperature constant up here. And then we're passing this in presumably all of our prompts. I see. Yeah. So wherever we create an agent, we're passing this as model settings with the temperature as an argument. All right. Well, let's give it a shot. I'll just say something fried, because now, after all these errors, I really need some comfort food. Ooh, I like that last one. Yeah, let's do the halloumi. That's a kind of sort of a very hard cheese that you can often eat fried. Hopefully we get the recipe back this time. Oh, there we go. Okay, pan-fried halloumi with za'atar. Now there's a bunch of output here. So it looks like it's downloading the Flux model now. So this might take a while. It's downloading many, many gigs. Okay, so actually troubleshooting all of this ended up being a little bit more difficult than expected. I had to make a couple of changes, but before we go over those, it actually just now finished successfully for the first time. I haven't looked at the result yet, so let's do that together. So since I had to rerun the pipeline, let's quickly scroll back up here, right? So I asked for a veggie stir fry this time, and then picked the first dish, so a Thai green curry stir fry with tofu and bamboo shoots. Okay, then we got the full recipe down here, which looks great. Pretty simple, actually, just 3 steps. And then we got the image prompt. So it chose to showcase the final dish. And the image prompt was a vibrant Thai green curry stir fry featuring golden tofu, bright red peppers, and bamboo shoots in rich coconut sauce. Overhead shot, natural sunlight, shallow depth of field, evoking fresh, aromatic warmth. Sounds great. So it downloaded the image models and loaded them into the GPU and all of that stuff. So let's take a look at the generated image together. So that should be here in the output directory. Ooh, that's pretty good, actually. The herbs look a little bit weird, like a little bit thick and rubbery, perhaps. The tofu looks pretty good, and the red peppers. So for a local model, it's not bad, actually. Let me quickly go over the changes I had to make. Every other time or so, I kept getting issues generating the recipe, similar to what we saw before. Reducing the temperature definitely helped, but I ended up following Claude's suggestion and switched from tool output to native output. So if we look at these functions here, right, this used to be tool output, and now we're using native output. And this achieves a similar effect. It's just a different mechanism underneath the hood. So these are the kind of things that you're going to need to experiment with, depending on the exact model that you're using, the exact framework, and all of that. Find the combination that works well for you. And then with the image generation, I kept getting issues with the right version of the Torch library. So I ended up having to be very explicit here about using the CUDA version of PyTorch. So I had to add these more explicit statements to my pyproject.toml file. With that, it downloaded the right version. And then I was able to actually generate the image locally. So a few detours, but now it's working. Let's make one more tweak and then actually kick it off again. So right now we just get the recipe once in the terminal, right? And then we get the actual image here in the output. So why don't we generate a Markdown file as output? So we should be able to get a nicely formatted recipe, including the image right in there. I am actually going to commit what we have first. I should add output to the git ignore. And since it's getting late and we've already enlisted Claude before, we'll actually just have Claude Code implement the Markdown support real quick. So I'll start a new chat. Okay, so let's try this. Please write the generated recipe to a Markdown file. Use the same timestamp-based file name approach we use for the image, but with a .md extension. The Markdown file should reference the respective image file at the top. Okay, there we go. Let's take a quick look here. Sorry, I'm getting lazy, but it legitimately is getting late. Okay, so recipe to Markdown, name, description, ingredients. Up here we have the image reference, instructions. Looks good to me. Let's try it out one more time. And we'll see if our pipeline is somewhat well-behaved now. We might need to tweak the temperature a little bit more or make some other changes. Could also try a totally different local model. So the Quen model or something like that. What are we in the mood for? Let's finish off with another dessert. A fancy dessert with ice cream. I don't know. Doesn't sound that fancy, but let's see what it can whip up. Oh, actually, that does look quite nice. I think I'm going to have to go with the first one there. So lavender honey panna cotta with pistachio crumble and vanilla bean ice cream. All right, let's do it. Okay. So far, so good. We got the recipe. We got the image prompt. So this time it's going to show the preparation stage. So a delicate lavender panna cotta in a glass bowl, topped with pistachio crumble and vanilla ice cream. Overhead shot, soft natural light, shallow depth of field, elegant, creamy, and floral mood. And since I'm talking, you kind of see the image generation in real time. So I'm not going to have to pause this. See, it just finished. So that's actually pretty reasonable for a local image model. And again, if you had more RAM, you might be able to keep both your Gemma model and the Flux model in RAM. It actually might be able to fit both in RAM. I could probably, look into that. I just told it to offload to CPU if needed. Anyway, let's go here. Okay, so now we have a Markdown file and an image file with the same sort of timestamp. So let's open this. And actually, let's do the Markdown preview. We might be able to get the image rendered nicely here. There we go. So here's what our Markdown looks like. So this could be, a blog post or something like that. So yeah, looks pretty nice. Definitely a panna cotta with some sort of granola on top, some pistachios, ice cream. You can clearly tell the lavender. Kind of a nice bokeh effect here as well. So I think that's pretty decent for a local image model. And then we got the actual recipe. Description, ingredients, instructions. This looks a little funky. Is that just the preview? No, it actually rendered it like this. So I think we still have a little bit of a bug in the Markdown rendering where it sort of adds double. Oh, I think I see what's happening. I think what probably happened is that, let's go back to the command line real quick. This is probably what the model returned, right? So it already added sequential numbers to the preparation steps. And then, of course, when we print it out, we add them as well. So those are redundant. But ideally, the model shouldn't be doing that. It should just be returning a list of steps without numbering, right? We can take care of that. So because that'll be rendering dependent and all of that. So maybe that's a quick fix that we can make here, just as an example of some prompt engineering. So if we go up to the recipe step, so this would be a good place to tell it not to add any numbering. In fact, we can probably do that in two places. An even better place is in the recipe itself. All right, ordered preparation steps, because we have the description, and I mentioned that these descriptions are actually important. So we say ordered preparation steps. Each list item is one step as a full sentence. So this is a perfect place to say, and I'll be really explicit here, do not add numbering. Yeah, actually, I'll just go with what Copilot suggested here. Do not add numbering or step 1, etc. Just the instruction text. And that might be enough, but just to make sure, I'm going to reinforce this in the system prompt as well. A little redundant perhaps, but this should be fine. So let's kick this off one more time. Let's just say a nice salad. Okay. Let's try the spicy Korean kimchi and sesame salad. Cool, there's the recipe. And there it's generating the image. So it does look like our tweaks to the generation helped. So switching from tool output to native output, at least anecdotally, right? I was able to run it like 3 times or so in a row now without getting issues. So I think that's pretty promising. And there it finished. So overall, the pipeline actually doesn't run very long. So let's open up our new recipe. That's this one. Open the Markdown preview. All right, that looks pretty decent. So there's our salad. And now the instructions look good. So we don't have any numbering in here. So perfect. I'm pretty happy where we ended up. So I'm going to go ahead and commit this to GitHub, add some notes to the README. Again, you'll be able to find a link to the GitHub repository in the description if you want to just clone it and use it as a starting point for your own experiments. And if you want to take this further and build a full production pipeline that does this kind of thing autonomously, like researching, analyzing, writing, generating images, I put together a free blueprint that walks through the architecture that I use for my Gamma Vibe startup idea generator. The link is also in the description. Finally, I'm also building a course around this pipeline, and the blueprint gets you on the waitlist. All right, thanks for watching and building with me. See you in the next one.